Hello and welcome to Antidifferentiation by Parts. This is an extension of the Calculus AP course. So we use the following formula below to determine the antiderivative of complex and combined functions. This actually stems from the idea that you take the derivative of u and v, you get u dv plus v du. Well, if you take the integral of both of these parts, you'll get d of uv dv, which cancels. These items, so you get uv and then you can rearrange from there. Okay, so the trick is to actually find a value of u when you select u to be something that simplifies when you take the derivative. So for example, if we're looking at for the integral of x dx, what you probably want to do is you want to let your function u be the function x, so when you take the derivative of u, it simplifies. And therefore, sine x dx is our value for dv. And therefore, v is actually the value of negative cosine x. So then you replace it. Your u and your v is negative x cos x together minus the integral, and in this case you're going to be using negative cos x dx, which is just the same as plus integral of cosine x dx, and now you can integrate that and you get this expression. Once you get these integrals, then you can find definite integrals instead of indefinite integral values and calculate them from there. So let's try a couple more examples. So let's evaluate the integral of ln x dx. So in this case, you probably want to let u equal ln x, because that can simplify to du equals into 1 over x dx. And that means your value of dv is just dx. So v with function x. So this is x ln x minus the integral of x times 1 over x dx. So you're just working out the integral of dx, which is just minus x plus c. Okay, so let's try another one. How about this one? So here I'm going to let u equal the expression tan inverse of x. And I can work out the derivative of this, which is 1 over x squared plus 1, or 1 x squared, 1 plus x squared dx. That means dv is equal to dx, and therefore again v equals x. So this simplifies to x tan inverse of x minus the integral. I'm going to multiply the x over the x squared plus 1 dx. Well, if I find out negative a half of the natural logarithm of x squared plus 1 plus c, that's the integral of negative x over x squared plus 1 dx. Now there is a possibility that there can be more complicated integrals where you can actually do more integration by parts. So you could use repeated possible integration by parts. You can also solve for the unknown integral using indefinite integrals or definite integrals. And there's also, you can take a look at examples 5 and 6 in the textbook to see some examples of tabular integration. We're not going to look at those again because this is an extension of the work we're doing. So based on that, you should be able to do what you're doing.